Hi, this is Mr. Ward. I'm going to do a quick video on the next few problems in Set A from Chapter 10, Section 4 on secants and tangents. I'm going to go fast on this. I'm going to ask you to pause before I do the reveal and try it yourself. You can skip around and bounce around as you need to. You don't have to watch all of this if things are making sense. So number 5, for each pair of circles illustrated below, tell how many common internal tangents and how many common external tangents can be drawn. All right, well, I'm going to ask you to really look at all of these and think about them. Pause the video, and then I'm going to start going through them A, B, C, D, and E. So I'm assuming you pause the video. We can get 2 common internal tangents. I am not drawing them very well. And we can get 2 common external tangents here and here. Assume those were tangents. Okay. And then B, if you needed to just see that first one, I'll try and draw these a little better. Consider B. Pause the video before I draw it, if you haven't done it already. Assume you paused. I will now draw 1 common internal tangent, and that's just right there. And I'll draw 2 common external tangents, just like that. Now consider C. Well, C, can't draw any common internal tangents because they would only be tangent to one circle. They would be secants for the outer circle. And cannot draw any common external tangents because they can't get inside if they're only tangent to the outer circle. And if they're only tangent to the inner circle, then they're internal secants to the outer circle. So that one is a no. 0, none of them. All right, so now go into number D, or letter D, and consider that. All right, you can only draw 2 external tangents. Can't draw any internal tangents because of the overlap. How about E? Well, we can draw 1 external tangent. We can't get any internal tangents for that. All right, let's move on to 6. Okay, for this one, we're going to be applying some similarity stuff and proportionality stuff. So on number 6, we were told CE is a common internal tangent to circles A and B, and it's tangent at C and E. So think about what that will mean for us. I will go ahead and note that it means this, for one thing, and this as well. All right, so consider how you could figure out that angles A and B are congruent and how you might work out this set of proportions. AD is to BD as CD is to DE. I assume you pause the video, and now you probably noticed that you have vertical angles, and we also have angle. Okay, so by no choice here, we've got those angles congruent as well. And so that's good. So A and B are congruent. And now, because they have the same angles, they are similar triangles. We cannot say they're congruent because we don't have any information about their side lengths. So AD corresponds to BD because it's between the same angles. And we also know that CD corresponds to DE. So we can say AD is to BD as CD is to DE. And so check, that one works as well, sets up a proportion because of triangle similarity. Okay, number 7, we've got QR and QS tangent to P. I'm just going to note that the 2 tangent theorem tells us this, and that's kind of nice, at points R and S. We're supposed to prove that PQ is perpendicular to RS. And this is a really simple one to do if you remember what radii do, and if you remember your perpendicular bisector theorems. Pause the video and see what you can do. I'm going to go ahead and assume you pause the video. So PR and PS are radii, so they're the same. So now we just know that Q and P are equidistant to RS, so perpendicular, and you could also note that that is perpendicularly bisected. Now let's go on to number 8. I'm going to pause and drag. So we're given PW and PZ are common tangents to those two circles, to circles A and B, at W, X, Y, and Z. Okay, so we've got all those points of tangency. We're supposed to prove that WX and YZ are congruent, and we won't have to draw any extra lines. So pause the video and see what you can do. All right, I'm going to assume you pause the video, and you probably already know that PW and PZ have to be congruent because of the two tangent theorem. And then you probably know that PX and Py have to be congruent because they are two tangents of the same circle coming from the same point. And so it's very easy to use subtraction to prove that XW and YZ are congruent. I'm going to stop this video and move on to the next part.